What's up YouTube? Welcome back to Intuition. Today's video we're going to be talking about polynomials. So when it comes to math, if you think about it, the only thing we really know how to do is add and multiply. Addition and subtraction are really the same thing. Once you increase your definition of numbers to include negative numbers, then you realize that addition and subtraction are really the same thing. 4 minus 2 is the same thing as 4 plus negative 2. And you also learn that multiplication and division are really the same thing. 4 divided by 2 is the same thing as 4 times 1/2. So really, when it comes to math, the only thing we really know how to do is add and multiply. And even as you move on to more advanced mathematics, you continue to do the same thing, add and multiply. It's just that the definition of addition and the definition of multiplication become more abstract. The only thing you really know how to do in your head is add and multiply. Okay, so that's where polynomials come in, because when you look at a polynomial, the only thing in a polynomial is multiplication and addition, right? You take some variable x, you multiply it by itself a certain amount of time, and then you multiply it by another number called a sub n, and then you add them all up, and that's what a polynomial is. A polynomial is the logical next step after you've learned how to add and multiply, because a polynomial is simply a function of multiplication and addition. And what this allows you to do is it allows you to explore some of the patterns that you can create with simple addition and simple multiplication. And the way that you start exploring the type of patterns that you can form is to look at the different patterns created by different polynomials of different orders. And of course, the order of a polynomial is the highest power that the variable is raised to within the polynomial. So the highest power contained within the polynomial is defined as the order of the polynomial. So let's take a look at a polynomial of order 0. If you have a polynomial of order 0, that's just a constant. That's a flat line. So that's a very simple pattern. There's nothing much there, right? But now, if you take a look at a polynomial of first order, of order 1, essentially what you have is a straight line. Polynomial of order 0 is a flat line. A polynomial of order 1 is a straight line. It's basically a linear equation. And of course, as you continue to look at polynomials of higher orders, you start to get more curvature within the function. So polynomials are very simple functions. And for those of you who have been following this channel for a while, you know that simplicity is always at the heart of complexity. So understanding polynomials is essential for us to be able to understand more complicated functions. We all know how to add and multiply, so we can all deal with polynomials. But what happens when we get something more complicated? For example, what if I ask you, what is e raised to the square root of 2? Now you might say, well, what is e? Well, e is just a number. E is just a number equal to about 2.71, right? So you just have a number and it's being raised to the radical 2 power. How do you do this without a calculator? When it comes to doing anything by hand, the only thing we know how to do is add and multiply. So you want to ask, what should I add and multiply to figure this out? Well, we know how to raise something to a power, right? For example, if it was e raised to the 2, we would just take the number 2.71 and multiply by itself. So it will be 2.71 times 2.71. And we can all do that by hand. But the issue with this problem is that it's e raised to the radical 2. So how do you raise a number to a power that is not a whole number? How do you do that? That's very confusing and very non-intuitive. But what if we were able to represent the function e to the x by a polynomial? Wouldn't that be nice? Of course it would be nice. And in fact, we actually can, because the function e to the x is approximately equal to a polynomial equal to 1 plus x over 2 over 2, all the way up to x to the n divided by n factorial. And n could be whatever whole number you want to go up to. We can approximate the value of e to the x to any level of precision that we want to. It all depends on up to which power of the polynomial we choose to use. Let's use this polynomial to approximate the value of e to the square root of 2 by keeping the first 5 terms of the polynomial. So let's go ahead and plug in the square root of 2 into this polynomial, which we know how to do because we know how to multiply and add numbers. So we would get 1 plus square root of 2 plus 1 plus the square root of 2 divided by 3 plus 1 over 6. And knowing that the square root of 2 is approximately 1.41, we can approximate this quantity here to be 4.05. And that is very close to the right answer of 4.11. Which is what e to the square root of 2 is. So the power of the polynomial is that it's a simple function that we can combine together to represent more complicated function. And that is a big part of why you spend a lot of time in your algebra class learning all about polynomials. And when it comes to polynomials, the main thing that you learn is how to factor polynomials. The essence of factoring polynomials comes from a property that is called the fundamental theorem of algebra. And that property says that any polynomial of some order n has exactly n roots, or n zeros. A zero is a certain value that x can take that will cause the polynomial to have a value equal to 0. A polynomial can always be represented as a string of multiplication of first order polynomials, where each of the first order polynomials is equal to the variable x minus one of the roots of the polynomial. And all of that will be multiplied by the coefficient a sub n, which is the coefficient of the highest order term in the polynomial. So let's go ahead and take a look at an example. For this example, I'm going to show you how to factor this polynomial in 3 different ways. The first method I'm going to be showing you is the most general method. The other 2 methods are going to be specific for factoring second order polynomials. So let's start with method 1. So we have a polynomial that is equal to x squared plus 3x plus 2. And we want to factor this polynomial. The key to factoring a polynomial is to find its roots. So we want to guess one of the roots of the polynomial, which means that we want to find a number that will make this polynomial be equal to 0. Now, when it comes to guessing the root, you always want to start off with simple numbers. 0, 1, and -1. Now, clearly 0 is not going to work, because if we plug in 0 in for x, we get 0 plus 0 plus 2, which equals 2. But you can kind of look at this polynomial and tell that -1 would work. Because if you plug in -1, you get -1 squared, which equals 1, plus 3 times -1, which equals -3, plus 2, and that equals 0. Perfect. So that tells you that one of the factors of this polynomial would be x minus the root, and in this case the root is -1, so we get x minus -1, which is x plus 1. So now that we have one of the factors of the polynomial, how do we get the remaining factors? Well, all you got to do is divide. For example, if you wanted to factor the number 6 and you know that the number 2 is one of the factors of 6, how do you get the other factor? Well, you just take 6 and you divide it by 2, right? 6 divided by 2 is 3, and therefore 3 is the other factor. So 3 times 2 equals 6. Same thing here. We need to divide the polynomial x squared plus 3x plus 2 divided by x plus 1. And we can do that with long division. So let's go ahead and do that. So the first thing we do here is we take a look at our divider, which is x plus 1, and we see that the highest power is x. So we take a look at the term x and we ask ourselves, how many times does x goes into the first term? So how many times does x go into x squared? X goes into x squared x times. So the first term of our quotient will be x. So we put an x up there, and then we multiply x plus 1 times x, and that gives us x squared plus x. Okay, and then subtracting our inside polynomial by this term gives us x squared minus x squared, which equals 0, and 3x minus x gives us 2x. And then we bring down the remaining term, which is 2, so we have 2x plus 2. And now we repeat the same process. X goes into positive 2x, positive 2 times, so we put a positive 2 up top, and we multiply x plus 1 times 2, which gives us 2x plus 2. And subtracting the difference gives us 0. All right, so we have a remainder of 0, and we're done. And therefore, our remaining factor is x plus 2. Therefore, this polynomial can be represented by x plus 1 times x plus 2. Okay, let's look at method number 2. Because this is a second order polynomial, we can use the quadratic equation to find the roots of this polynomial. And the quadratic formula is the roots are going to be equal to -b plus or minus the square root of b squared minus 4ac all over 2 times a. All right, and all we got to do is plug and chug. And when we do this, we get -3 plus or minus 1 all over 2. And we go ahead and calculate our plus and minus terms, and we get -1 and -2. So -1 and -2 are the 2 roots of our polynomial, and we can use these to get the factors. Because remember, the factor is going to be x minus the roots, and x minus -1 is going to be x plus 1 times x minus -2, which is x plus 2, and therefore this polynomial factors into x plus 1 times x plus 2. All right, so let's go on to a third method, which is another method that is specific for second order polynomial. So method number 3 says you want to isolate the b term up top, and then you want to isolate a term on the bottom called the coefficient a times the coefficient c. And essentially what you want to do is you want to find 2 numbers, which are not necessarily the roots of the polynomial. These are just 2 numbers, but you want these 2 numbers to have the property that they multiply to equal a times c, and they add to equal b. And once you find those 2 numbers, n1 and n2, this polynomial is basically factored by the formula 1 divided by a times x plus n1 times a times x plus n2. So let's go ahead and factor our polynomial using this method. So in this case, b equals 3 and a times c equals 2 times 1, which equals 2. So essentially, we want to find two numbers that multiply to give us 2 and add to give us 3. Well, what two numbers will do that? 2 and 1. 2 times 1 equals 2, and 2 plus 1 equals 3. So the two numbers that we're looking for are 2 and 1. So now we can just plug these two numbers into our formula. 1 over a, in this case a equals 1, so that's just 1. We don't need to write that. And we have ax, which is just x, plus n1, which is 2, so we have x plus 2. And we have ax, which is again x, plus n2, which equals 1, so that's x plus 2 times x plus 1. And that is how this polynomial factors into. We have three different methods and we got the same answer. So that's how you factor polynomials. Every polynomial of a certain order has a given number of roots that can be used to factor the polynomial. That is the essential principle that you need to take away from studying polynomials. So hopefully this video was helpful. Hopefully you got something out of it. If you appreciate what we do here at Intuition, go ahead and give the video a like, go ahead and subscribe to the channel, and even share our videos. The year is coming to an end. I'm going to be releasing a video soon about how well this channel has done this year, where we fell short, where we can improve. I'd like to hear from you guys, so definitely go ahead and interact with us, get to know us. We're happy to have you here on this channel, and we're always trying to grow and improve our content. So go ahead, keep liking, keep sharing, and let us know how we're doing. With that said, I'll see you guys in the next one. All right, bye-bye.